The fourth problem of semifinal number 2, 2006 MIT integration B, is the definite integral from x equals to 1 to x equals to 2 of the square root of x squared minus 1. Now this is, I think this problem tests one on the knowledge of hyperbolic functions. So let's go ahead and see how we may be able to solve this. So the first thing I would do is I'll substitute for x, since I know that hyperbolic cosine squared of x minus hyperbolic cosine squared of x, sine of x is 1. This relationship is key since we can gather that hyperbolic cosine squared minus 1 is equal to the hyperbolic sine squared of x. So knowing this, it's important to say that let x be equal to the hyperbolic cosine of u, such that dx du is the hyperbolic sine of u, and so we can substitute for the hyperbolic sine of u. We can substitute for dx with the hyperbolic sine of u du. And so the lower limit obviously becomes the arc hyperbolic cosine of 1. Upper limit is arc hyperbolic cosine of 2. And so in place of x, we have hyperbolic cosine of x. So this becomes hyperbolic cosine squared x, hyperbolic cosine square of u minus 1. And then in place of dx, we have hyperbolic sine of u. So this becomes this square root, it becomes hyperbolic cosine of u, sine of u. And it's a known fact that the arc hyperbolic cosine of 1 is 0. So the lower limit just goes to 0. And so you have these two hyperbolic sine of u multiplied together, so that becomes hyperbolic sine of u squared. We can try to transform things by using, since we know that hyperbolic sine of u is e to the u minus e to the negative u divided by 2. So when you square that, we get this divided by 4. And then we can bunch this together so that we do now have a half the hyperbolic cosine of 2u minus 1, because 2 divided by 2 that we've taken up from this a quarter. And so we have a half the integral from u equals to 0 to the arc hyperbolic cosine of 2 of cosine 2u minus 1. And that means that we have half of the hyperbolic sine of 2u minus u when you integrate this. That becomes half, open bracket, this half of sine of twice the arc hyperbolic cosine of 2 minus the arc hyperbolic cosine of 2 for this 2 there. And then on the lower limit, at 0, sine of hyperbolic cosine sine of 0 is 0. This is u is 0. This is 1 and this is 1. So this becomes 0. Now we can simplify this further. This is obviously an answer, but we can simplify it further and say that hyperbolic sine of 2 arc hyperbolic cosine of 2 is the same as twice sine of arc hyperbolic cosine of 2 times cosine of arc hyperbolic cosine of 2, since we know that sinh of 2x is equals to 2 sinh x times cos x. So using this expression, and this straight becomes 2. Now you can cancel that. The question is, what is this? Right? Using the elementary relationship that we had shown, sinh is the same as cos squared minus 1 square root, and so substituting it there, we have 2 squared, which is 4 minus 1, and we already show that this is 2. So this becomes square root of 3. So we have half square root of half times 2 times square root of 3 minus hyperbolic cosine of 2 is log of 2, or natural log of 2 plus root of 3. And how one would show that is if we have this being equal to 2, then it means that x plus is equals to 4, and that means if we multiply across by e to the 2x, we have, use the x, we have e to the 2x plus 1 is equals to e up to the x. Bringing this side, we have, this becomes e to the x minus 2 squared minus 4 plus 1 equals to 0. This becomes minus 3. So we have e to the x minus 2 squared equals to 3. E to the x minus 2 is equals to root 3. We will take the positive side because e to the x is always positive. So we have e to the x equals to 2 plus root 3. And so x is equals to log of 2 plus root 3. So this is how you would be able to detect that cos of x being equal to 2, in other words, arc cos of 2 implies that x is the natural logarithm of 2 plus root 3. And so this is our answer, but we could simplify this further by saying, okay, this is root 3 minus a half of the natural logarithm of 2 plus root 3. So our final answer, we could express this as the square root of x squared minus 1 integrated from 1 to 2 is root 3 minus half of the natural logarithm of 2 plus root 3. And that is the answer. So until next time, I hope you have a good time. Bye-bye. Tutaluka la question form.